Okay, so part A says that to write an equation for the line tangent to the graph of f at x equals 1. So first we're going to find the derivative of f of x. And then we're going to find the derivative at the point of x equals 1. After that, we're going to plug it into the point slope formula. Which is going to be this. And this is the equation for the line tangent at the graph of f at x equals 1.
Letter B asks for the area of R. R is a region that is enclosed by the f of x and the x-axis. So first, the formula to find the area of under a graph is AB. This is the formula. Now we have to plug in the values. The limits are going to be from 0 to 1. F of x is e to the 2x dx. We find the derivative of that, which is equal to e to 2x over 2 from 0 to 1, and then we plug in, and it gives us
Okay, so for problem C, region R forms the base of a solid whose cross-section perpendicular to the y-axis are squares. Write down, but do not evaluate, an expression involving one or more integrals that gives the volume of a solid. So here's f of x. The first thing that you have to do is change it in terms of y. So you basically have y equals e to the this, and then you have to solve it for x, which ends up being ln of y over 2. After having this, you have to use the equation, which is this, the integral from a to b of the area of cross section dy because it's actually asking you for the x-axis. And then you actually have to plug in, which is 0 to e to the 2 because of this. And then you put 1 because 1 it's the actually outside function. So you put the 1 minus this equation, which is 1 over 2 ln y to dy in terms of what? Dy. And that's the answer because it's not telling you to solve it, but to only not to evaluate it, but like just the equation. And of course, please.
perfect.